September 27th, 1942, 7:35 in the morning, Willow Run, Michigan. Inside a building that stretched more than a mile in length, the sound of machinery had already begun to echo across the factory floor. Rivet guns snapped in rhythmic bursts. Overhead cranes carried aluminum fuselage sections slowly down a moving assembly line. On the concrete below, thousands of workers moved in carefully timed sequences between jigs, scaffolding, and partially assembled aircraft. At Station 47, a team of mechanics secured the 14th bolt on the engine mount of a consolidated B-24 Liberator bomber. The engine that would soon hang from that mount was a Pratt & Whitney R-1830 Twin Wasp, an 18-cylinder radial engine capable of producing 1,200 horsepower. 4 of those engines powered every Liberator, and the aircraft rolling down the line at Willow Run were not experimental machines. They were frontline heavy bombers destined for the air war over Europe. But only 12 months earlier, none of this existed. In April of 1941, the United States Army Air Corps faced a logistical problem that few military planners had ever attempted to solve. Strategic bombing doctrine required massive numbers of heavy bombers. Aircraft such as the B-17 Flying Fortress and the B-24 Liberator were expected to attack German industrial targets hundreds of miles inside occupied Europe. But producing heavy bombers required specialized aircraft factories that could only build a handful each month. Even the Consolidated Aircraft Plant in San Diego struggled to produce more than a few Liberators at a time. The United States War Department needed something entirely different: mass production. The solution came from an unlikely direction: the Ford Motor Company. Henry Ford had spent decades perfecting moving assembly lines that produced automobiles at unprecedented speed. His factories had transformed the American automobile industry by replacing skilled craft production with industrial-scale manufacturing. In 1941, the War Department approached Ford with a radical proposal: build heavy bombers using automobile production methods. Ford engineers selected a flat stretch of farmland near Ypsilanti, Michigan. The location allowed rail connections, nearby airfields, and access to the vast industrial workforce of Detroit. Construction began in the spring of 1941. The building that emerged was enormous. The Willow Run plant measured more than 3,300 feet in length and covered roughly 3.5 million square feet of floor space. The assembly line followed a distinctive L-shaped path designed to avoid railroad property that could not be relocated. Inside that structure, Ford engineers attempted something never before done in aviation history: build heavy bombers using a continuously moving assembly line. But early production quickly revealed a serious problem. Automobiles could tolerate minor variations in parts. Aircraft could not. The B-24 Liberator required extreme precision. Wing spars, engine mounts, hydraulic systems, and bomb bay doors all demanded tolerances far tighter than automobile manufacturing allowed. During the early months of 1942, the Willow Run line struggled. Subassemblies arrived late. Parts from different contractors did not always fit together. In one case, workers discovered that several fuselage sections had been produced with slightly misaligned rivet holes, forcing entire assemblies to be reworked. Production slowed. Military planners watching the program began to worry, because by mid-1942, the air war over Europe was intensifying. The United States Army Air Forces had activated the 8th Air Force in England. Heavy bomber groups were arriving steadily across the Atlantic. Units such as the 97th Bombardment Group and the 44th Bombardment Group were preparing to fly long-range missions against German industrial targets, but aircraft losses were already significant. German fighter units flying Messerschmitt Bf-109 and Focke-Wulf FW-190. Interceptors were proving extremely dangerous. Anti-aircraft artillery around targets, such as Bremen, Hamburg, and the Ruhr Valley, could damage or destroy dozens of bombers in a single raid. Heavy bomber doctrine assumed those losses. The plan depended on one critical factor: replacement aircraft had to arrive faster than the enemy could destroy them. This was the strategic purpose of Willow Run. By the autumn of 1942, Ford engineers reorganized the entire production system. Subassemblies were broken into thousands of standardized components. Separate contractor factories across the United States produced wings, landing gear assemblies, electrical systems, and bomb bay mechanisms. Rail lines delivered these parts directly into the Willow Run complex. Workers on the line no longer built aircraft from scratch. They assembled them like industrial machinery. By early 1943, the system began to work. The first Liberators rolled off the line at a pace that surprised even the War Department planners. But the real test had not yet come, because the 8th Air Force in England was about to launch deeper and more dangerous bombing missions into the heart of Nazi Germany. Missions that would demand hundreds of bombers in the air at the same time. And every one of those aircraft required engines, airframes, and replacement crews that could only come from one place: Willow Run. But inside the vast factory in Michigan, another problem was quietly building: a production bottleneck that threatened to slow the entire Allied strategic bombing campaign. And if that bottleneck could not be solved, the bomber offensive over Europe might stall before it ever reached its full strength. March 10th, 1943, 9:15 in the morning, Willow Run Bomber Assembly Line, Michigan. At Station 112, a crane operator carefully lowered a Pratt & Whitney R 1830 twin Wasp engine toward the wing of a partially assembled B 24 Liberator. The engine weighed roughly 1,300 pounds, 18 cylinders arranged in 2 radial rows. A 2-stage supercharger mounted behind the engine block allowed the bomber to maintain power at high altitude. The aircraft required 4 of them. Without those engines, the bomber line stopped. By early 1943, Willow Run had begun to approach the production speed the War Department demanded. The factory workforce had expanded to more than 40,000 workers operating around the clock in rotating shifts. The assembly line itself moved slowly but continuously. A Liberator airframe entered the line as a collection of structural components. Aluminum wing spars arrived by rail from Ford subcontractor plants. Fuselage sections, built by outside contractors, were delivered on flatbed train cars and lifted directly onto the line. Every 58 minutes, the aircraft moved forward 1 station. At each station, a specific task was completed. Fuel tanks installed, electrical wiring routed through fuselage frames, hydraulic systems connected to landing gear assemblies, control cables threaded through pulleys that ran the entire length of the aircraft. The system resembled automobile production in rhythm, but the machines being built were far more complex. A single B 24 Liberator contained more than 100,000 individual parts. Even minor delays could ripple down the line and halt production. And by March 1943, one delay had become impossible to ignore. Engines. The Pratt & Whitney R 1830 Twin Wasp was one of the most widely used aircraft engines of the war. Variants powered not only the B-24, but also aircraft, such as the Douglas C-47 transport and the consolidated PBY Catalina patrol plane. Demand from every theater of the war was rising. Factories producing the engines were running at maximum capacity. Shipments occasionally arrived late. When that happened, completed bomber airframes accumulated on the line without engines to install. Ford managers watched the backlog grow. At one point, during the spring of 1943, dozens of nearly completed Liberators sat inside the factory waiting for power plants. Strategically, the delay could not have come at a worse moment. Across the Atlantic, the 8th Air Force was expanding its bombing campaign. General Ira Eaker, commander of the United States 8th Air Force, believed daylight precision bombing could destroy German industrial capacity. Factories producing aircraft engines, ball bearings, and synthetic fuel had become primary targets. But those missions required large bomber formations. American planners believed that tightly packed formations of heavy bombers could defend themselves using overlapping defensive gunfire. Each B-24 carried up to 10 50 caliber machine guns positioned in nose turrets, dorsal turrets, tail turrets, and waist gunner positions. The theory depended on numbers. A handful of bombers could be overwhelmed by intercepting fighters. Hundreds flying together formed a defensive box that was much harder to penetrate. But assembling those formations required a constant flow of replacement aircraft. Losses during early 1943 missions sometimes exceeded 10% of the attacking force. At that rate, entire bomber groups could become combat ineffective within weeks if replacements did not arrive. Willow Run was expected to solve that problem. Ford production managers reorganized the line again. Instead of installing engines at a single station, they created a staging area where incoming engines could be inspected and prepared in advance. Specialized teams checked ignition systems, fuel injection lines, and supercharger housings before the engines ever reached the aircraft. The change saved critical minutes at installation stations. Meanwhile, additional engine shipments began arriving from Pratt & Whitney plants in Connecticut. By the summer of 1943, the line accelerated. Liberators moved forward more smoothly. At peak efficiency, Willow Run began producing aircraft at a pace never before seen in aviation. Nearly 1 bomber every hour. The impact of that production surge soon appeared in the skies over Europe. Bomb groups flying from bases in eastern England began receiving steady deliveries of new B-24 aircraft. Entire replacement squadrons arrived, equipped with bombers that had left the Willow Run line only weeks earlier. Targets deep inside Germany that had once been considered unreachable now fell within range. But the increase in bomber strength triggered a reaction from the German air defense system. Luftwaffe fighter commanders quickly realized that American bomber formations were growing larger and more frequent. Interception tactics evolved. German units began coordinating mass attacks using heavily armed fighters equipped with 20mm and 30mm cannon. The skies over Germany were becoming more dangerous, and despite the rising output from Willow Run, the demand for bombers was about to grow even larger. Because by the autumn of 1943, Allied planners were preparing for a series of bombing missions that would push the strategic air war to its most dangerous stage yet. Missions aimed at targets so heavily defended that even massive bomber formations might not survive intact. The success of those operations depended on one uncomfortable truth. Factories like Willow Run had to produce aircraft faster than the enemy could destroy them. But as bomber losses began to climb during the second half of 1943, military planners started asking a difficult question. Could even the largest aircraft factory in the world keep up with the coming air battles? October 14th, 1943, 12:20 in the afternoon, above central Germany. Hundreds of American heavy bombers moved east in layered formations stretching across the sky. Inside, the lead elements were aircraft from multiple United States Army Air Forces units, including the 44th Bombardment Group and the 93rd Bombardment Group. Many of the bombers flying that day were consolidated B 24 Liberators that had rolled off the Willow Run assembly line only months earlier. Each aircraft carried a crew of 10, pilot, co-pilot, navigator, bombardier, flight engineer, radio operator, and 4 gunners operating defensive positions armed with 50 caliber Browning machine guns. Together, they formed the backbone of the American Daylight Strategic Bombing Campaign. The objective of missions like this was simple in concept but complex in execution: destroy the industrial system that allowed Germany to continue fighting the war. Factories producing aircraft engines, synthetic fuel refineries, ball-bearing plants, and transportation networks were all critical targets. If those facilities could be damaged faster than they could be repaired, the German war economy would slowly collapse. But reaching those targets meant flying deep into heavily defended airspace. German air defense commanders had spent years building a layered system designed to stop bomber formations. Radar stations detected incoming aircraft while fighter units waited at airfields across the country. Anti-aircraft batteries protected major cities and industrial centers. The deeper the bombers flew into Germany, the more intense the resistance became. And when German fighter units attacked in coordinated waves, losses could become severe. Strategically, that was where the industrial power of the United States changed the equation. Back in Michigan, the Willow Run plant had reached its full production rhythm by early 1944. The assembly line now operated with extraordinary efficiency. Sections of the aircraft arrived from dozens of subcontractors across the country. Wing panels, landing gear assemblies, hydraulic pumps, and electrical wiring harnesses were delivered in a carefully timed logistical network that connected factories from California to Ohio. Workers at Willow Run assembled those components into completed aircraft, moving slowly down the mile-long line. At peak production during 1944, the plant produced more than 600 B 24 Liberators every month, nearly 1 bomber every hour. That output had a direct effect on the strategic bombing campaign. When bomber losses occurred over Europe, replacement aircraft were already moving through the production system. New bombers crossed the Atlantic by ferry route or aboard aircraft carriers modified to transport crated airframes. Within weeks, depleted bomb groups could return to operational strength. The scale of production forced German planners to confront a reality they had not anticipated. Even successful interceptions could not permanently reduce Allied bomber strength. For every bomber shot down, another was already leaving a factory line. This imbalance began to affect the map of the war. By mid-1944, American and British bombers were striking targets across occupied Europe and inside Germany itself. Synthetic fuel plants in the Ruhr region came under repeated attack. Railway junctions, aircraft factories, and oil refineries were bombed again and again. The cumulative damage began to slow German production. Aircraft factories struggled to replace losses. Fuel shortages reduced pilot training hours. Transportation networks became increasingly unreliable as rail yards and bridges were destroyed. All of these consequences traced back to one strategic advantage: industrial scale production. The Willow Run plant symbolized that advantage more clearly than any other single facility. Over the course of the war, the factory produced more than 8,600 B 24 Liberators. It became the largest aircraft manufacturing plant in the world and demonstrated that the United States could convert industrial capacity directly into military power. But the true significance of Willow Run was not simply the number of bombers it produced. It was the strategic chain reaction that followed. Mass production allowed sustained bombing campaigns. Sustained bombing campaigns damaged industrial infrastructure. Damaged infrastructure weakened the German war economy, and that economic pressure reduced the ability of Germany to continue large-scale military operations across Europe. By the final year of the war, Allied bombers operated over Germany in numbers that would have been impossible in 1942. Thousands of aircraft participated in coordinated operations that targeted transportation systems, oil production, and remaining industrial centers. Behind those formations stood the workers, engineers, and assembly lines that kept the bombers flying. In quiet farmland outside Ypsilanti, Michigan, the machines inside Willow Run continued to move. Riveting, welding, assembly. One aircraft after another rolling down the line. Not weapons in isolation, but pieces of a much larger system that connected American factories to the skies over Europe. A system that turned industrial production into a strategic force capable of reshaping the outcome of the war.